So this distance vector routing algorithm is basically based on dynamic programming, right? So let's talk about some of the basics of this distance vector routing algorithm before discussing the algorithm in detail. So we are interested in discussing distance vector algorithm. So this distance vector routing algorithm is based on its origin is basically the class of algorithms known as dynamic programming. So I hope you might have covered the dynamic programming in your design analysis algorithms class, but here, this word dynamic means this means multi-stage. Or time-varying process. Time-varying process. And programming, obviously you're familiar. The programming means planning, or we can say decision making. Decision making by a tabular method, specifically if we talk about this distance vector algorithm by a tabular method. Right. So this distance vector routing algorithm is based on basically dynamic programming, and the word dynamic means there is multi-stage or time-varying process, and programming we are familiar with means we are planning, we are solving, we are making a decision by solving something there by using a tabular method. So we use this dynamic programming when a problem can be divided into subproblems that overlap. So dynamic programming is used when a problem can be divided into overlapping subproblems that overlap. Okay, and we can solve each of these subproblems once, and then store its solution, say in a table, right? And if, for example, the subproblem is encountered again, we can simply look up its solution in the table. So we can like reconstruct the solution to the original problem from the solutions to the subproblem, right? So this means the more overlap is the better, as it reduces the number of subproblems, right? So so basically what it does is, so it solves each subproblem once and store the solution say in a table. And whenever we, encounter the same problem, so we do not need to compute it again and again. So what we can do is we can reconstruct. So this means we can reconstruct the solution solution to the original problem. From the solution to the subproblem, right? From the solution to the subproblem. All right, so that's why if more overlapping is there, so this will reduce the number of subproblems. Usually, this dynamic programming is used to solve optimization problems, right? So we use dynamic programming to solve optimization problem. For example, you're asked to find the shortest. Please find the shortest, or maybe best, the best way of solving a problem or doing something. Okay, so in other words, there must not be an optimal solution that contains suboptimal solution to a subproblem. This is very important to note. So this means there must not be an optimal solution that contains suboptimal solution to a subproblem, obviously, to a subproblem. Okay, so the solution of the subproblem has to be optimal also in order to have the optimal solution of the problem, right? So this distance vector was initially proposed by Bellman, right? So Bellman in 1957 proposed Bellman's shortest path algorithm, right? Bellman's shortest path algorithm. And initially, it was centralized. It was not distributed, because we know distance vector routing algorithm is distributed in nature, right? So initially, it was centralized, distance vector algorithm. So initially, it was centralized distance vector algorithm. Then later on, Fulkerson in 1962 modified the centralized algorithm proposed by Bellman to propose a distributed version, right? So Ford person in 1962 modified the originally proposed algorithm by Bellman, modified Bellman's algorithm. To a distributed version, right? And by the way, this distributed version is also known as Bellman-Ford algorithm, right?